Hi everyone, now for problems number 7 through 12 on the end of year assessment. Let me guide you through those. Here we go. All right, for the first section today, and you're going to want to be on page 127 at the bottom. It starts with these rules for the order of operations. So if you've forgotten those, this is great because it reminds you of the rules. Remember, we do everything that's inside the parentheses first. And if there's more than one thing going on inside the parentheses, we always follow these rules 2 and 3 when we're working in there. Always multiply or divide in order from left to right before we do any addition or subtraction. After you do all the multiplication and division, then you go ahead and you add or subtract in order from left to right. So it doesn't matter which one comes first, addition or subtraction, we go in order from left to right. So number 7, letter A, you use the order of operations to solve these number sentences. So you're going to go ahead and solve this one, and then you're going to go ahead and solve this one. And then it says, explain why the two number sentences have different answers. So this down here, I would be looking for 2 sentences. I would like you to go ahead and work on that problem. And then I want you to do number 8. Number 8 is super similar to what we just did. I believe it was like last week, Thursday or something. It says, Edie is planting a 6-foot by 15-foot flower garden. She is planting sunflowers in one part, and you can see the sunflowers labeled right here, and daisies in the other part. Write one or more number models that represent how you can find the area of the garden. So last week we did this with beans and carrots, and then remember in the end we figured it all for all together. So good luck on that one. If I were you, I would do 2 number models down here using that break apart strategy. Number 9, a collection of 6 movie tickets is shared equally among 3 families. How many tickets does each family get? What fraction of the collection of movie tickets does each family get? So each family gets a fraction of the tickets. So think about how many they get out of how many there are total. And then we have fraction memory. Fraction memory, let me remind you of what fraction memory is. Fraction memory, you are using fraction cards to try to see, are these fractions equivalent? Is one greater than the other one? Is one less than the other one? But Marta turns over these 2 cards during fraction memory. And the question is this a pair of equivalent fractions? And then you have to tell me if you agree or disagree, so yes or no. And then you have to, and I wrote down on yours, circle yes or no. And then you have to explain your thinking. And then it says, use your fraction cards to find a pair of equivalent fractions. I erased that and wrote, please partition and shade another pair of equivalent fractions. And I drew you 2 circles here so that you could practice showing equivalent or equal fractions. And then I want to know, how do you know that those 2 fractions are actually equivalent? Going on to the next page for questions 11 and 12. For 11 and 12, 11, you're doing different comparison symbols there, and I wrote you a tip on your actual test in this area to explain what those symbols mean, and you need to compare those fractions and whole numbers to each other. And then what do you notice about the fractions in part A and B? So that's talking about, what do you notice about this fraction comparison and this fraction comparison, and you're answering that right there. Number 12, this is very similar to a test question that we had within the last quarter, where if you take beaker A and you take beaker B and you put them into beaker C, will beaker C be full? So will it go all the way up to this 1,000 milliliters? And then you're going to put yes or no. And then it says, what volume of water will be in beaker C after you pour these 2 beakers, A and B, into it? And then you have to tell what the volume will be and include the units. And then you have to shade beaker C to show the total liquid volume. How much more water would you need to fill beaker C? Go ahead and do those problems today. Great job. Keep it up.